Yes, yes, I did. Because he was like, he contacted the company and was like, yeah, my thing is defective. It was like after 2 weeks. It broke.
Austin Burton, he got an iMessage.
Oh yeah, he sends me on this.
Isn't it still text? Tell me your passcode.
He's covering his face.
Okay, what numbers did we do? Number 12, square root of 3 over 2. Number 14, square root of 2 over 2. Number 16, square root of 3. Number 18, sine of x. Number 20 is negative sine of x. Number 22 is negative tangent of 6 theta. 24 is somewhere. 26, 25, where is 24? I don't know. We'll come back to 24 when I find it. Number 26 is the square root of 3 minus 3x squared, all of that plus x, and then everything over 2. 28 is x plus the square root of 3 minus 3x squared, all over 2. Number 30 is square root of 3 minus 4x times the square root of 1 minus x squared, all over 4x squared minus 1. 32 is over here. 32 is it works, and 34 is it works. Right?
Did you find the answer to 24?
No, I didn't find the answer to 24.
Can we do 24?
Sure.
What was your answer?
One question mark. There's not even any question marks in the problem. What you talking about?
It was a sine of x plus the square root of 1 minus x.
Yeah, that sounds more than one question mark.
Then add x squared and then another x, the negative x squared, so they cancel out. And I'm like, wait a second, that's I don't know if I can do this.
Then can we go over one validity problems because I don't know if I found them to where they were verified, but I don't know if I just made it happen.
If you cheated, is that what you're saying?
Or is cheating in math class? Why are you cheating?
Okay.
Stuff right now, it's just doesn't actually work.
Did I do something illegal? I got you. All right, what should we do?
Make triangles.
Okay.
Yes.
I like making triangles. A couple of triangles.
Triangular
Triangles. I think the triangles are like triangles.
Okay, now what?
Now we're gonna fill this stuff with sine minus the sine of x is in almost and one. And then yeah. And then
And then we're going to find the other side, which actually would be the same thing, so we just got to do it once.
Wait, why is it alpha? Because he's using that variable.
Those are the angles, bro.
Why are you doing the variable of the side?
I'm doing the same freaking thing we did last. Why are you asking silly questions, bro? Calm down.
I was thinking it looked too close to the alpha and not.
You thought you were putting an angle there.
Yeah.
Angle. Oh, I see. I follow you now. Now I understand. That's x squared and the square root of 1 minus x squared. Great. Grand. Glorious. Now what?
We do the formula of this addition, which is sine times alpha times cosine beta plus sine cosine of alpha times sine of beta. Yeah. We were right there.
You were just copying from the book.
I wasn't looking at it.
No, we're copying from your brain cells. They're part of you. You're copying from it.
What's the sine of alpha?
X.
What's the cosine of alpha?
Square root of 1 minus x squared.
What's the sine of beta?
Square root of 1 minus x squared.
What's the cosine of beta?
X.
Great.
We did it a lot. It's kind of weird. Who we are. Who we know.
Wait.
I know what I did wrong. Yeah. I skipped this step.
That's not helpful. Helpful in general.
I'm just letting you know what it was.
That was easy.
Yeah, it was, but I left that step. Yeah, I messed up. I plugged in a variable straight into the equation without changing it to the other one.
Good job. Any other questions for this lesson?
Can we go over 32?
Sure.
Let's go over 32, guys. I think 32 would be a great question.
I think you're wrong.
Verifying cofunction identities. Okay. Okay. So, supposed to verify that? Great. Now what?
Should we get some triangles? Do we need triangles? I didn't use triangles, but I didn't know how I was going to deal with the tangent equation. So I put the sine equation on top of the cosine equation.
Let's do it with the tangent equation.
Let's do it with the It's too hard to think about, so I just like...
Okay, so what is the tangent equation?
The tangent of the first angle, yeah, plus the tangent of the second angle. No, minus. It's minus. It's the same side on top and different side on the bottom.
Over 1 plus
Minus, no plus, yeah. Plus the tangent of the first angle times the tangent of the second.
We made that more complicated.
Yeah, we changed every side, at least one.
Okay. So, from over here, what?
Tangent of pi over 2 minus tangent of over 1 minus tangent of x pi over 2.
Great. Now what?
No, let's think about it. We cry because we can't solve it.
I can solve it.
Yeah, I couldn't solve it. Oh, find the value of pi over 2 and pi over 2.
That's a great idea. Finding the value of tangent of pi over 2. That's a great idea. Oh no. You're sunk. It's undefined.
You sunk my battleship.
Let's turn it into sines and cosines.
Turn it into sines and cosines, guys. Heck yeah. Heck yeah. Ooh, yeah.
Now what?
we expand.
Expand.
We turn it from that to the big equation.
Oh yeah. You know it.
That was a little bit sensitive. That card is right now. It is. You know which one I was talking about.
I haven't died.
So do I. It's not that big.
It's from high and large. Mine just probably
Give yourself a one.
I have a 6 semester set.
He's been
Just because you own a whetstone set doesn't mean you know how to use it. Just watching videos doesn't guarantee you know how to do the thing. You provided no evidence yet that he has a sharper knife.
Do the paper test.
And also the paper test, and it did cut the paper. And it did not cut the paper before I did the paper test.
When I take my knife, I can cut the paper real easy. Cut it. Okay. Okay, now what?
We plug it in.
Times the cosine of x minus the cosine of pi over 2 times the sine of x over the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. Put away the jangles, please. Put them away. Make them go away. Nobody cares about your jangly EDC. What now?
Now, sine of pi over 2 is 1, and cosine of pi over 2 is 0.
That makes our lives a lot easier.
It does.
And so it becomes
Cosine over sine, which surprisingly equals cotangent. We did it. Great. Let's learn the next lesson, shall we? The last lesson in this test. What kind of nonsense are you saying?
You said the last lesson in this test.
Last lesson in this test. The next test will cover all the things through here. It's not complicated. English is Englishing. Not that big a deal. We got this.
What is this lesson called?
Why don't you read for yourself? Because you're annoying me right now.
Definitely 6.1.
Pre-cal is the only class that I say stuff like that in. Isn't it fun?
Reduction. What did you say again? Multiple?
I said, y'all read it for yourself because you're annoying me right now.
That is not that's fair.
I have made a decision, by the way. Let me go through that real quick. You are going to have a identity chart on the test that includes some of the identities. It will have the following. Are you paying close attention? It will have sum to product identities. It will have product to sum identities. You haven't learned them yet. That's this lesson. It will have half angle identities on it. It will include double angle identities. It will also include anything else? Is there something else that I'm dreaming of? Let's see. Anything else? Or is that it? I think that might be it. Yeah, that's literally it. That is what your chart will include. Nothing else. So it's not going to do cofunction. It's not going to do Pythagorean. It's not going to include odd, even, any of that stuff. Reciprocal. You need to have those memorized. I've been telling you for ages that you need to memorize them. If you haven't listened to me yet, that is on you, not me. Now, let's learn some new identities, shall we? Let's learn some double angle identities. All the single angles? All the single angles. The sine of 2 theta equals 2 times the sine of theta times the cosine of theta. The tangent of 2 theta equals 2 times the tangent of theta over 1 minus tangent squared theta. And cosine, because he's friendly, has 3.
Wait, that could help us or make everything hard.
Both are possible. The cosine of 2 theta equals the cosine squared theta minus the sine squared theta. And that would have been lovely, and then, that would have been like cosine's magic. It would have been nice, but that's not how the world works. Cosine of 2 theta also can equal 2 cosine squared theta minus 1. It can also equal all of these. Most of these are derived in some way, shape, or form from Pythagorean identities. We could derive them ourselves if we wanted to, but we're not going to do that right now. It's why they look kind of vaguely similar, right? Cosine of 2 theta is 1 minus 2 times sine squared theta.
In all of these, there's just one thing that keeps it from just making everything simple.
Right. They do show you a way that some of these are proved, right? They're proved using the sum identities, right? So 2 theta is theta plus theta, right? So you can just shove stuff back up into the previous ones, the sum difference ones, and then you get these, right? That they kind of show you how that works. Let's do a couple examples using these. If the cosine of 3/5 on the interval 0 to 2 pi, I can read. If the cosine of, no, I've got this, we got it. If the cosine of theta equals 3/5 on the interval 0 to 2 pi, so AKA quadrant 1, right? Find the sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta. Okay, making sense so far? Yeah, you can read too. Good job.
But 6/5 isn't in the first example. What example is this? It's 3/5.
It's not an example. It's a guided practice. If you want an example, you can look up above there. Right? That's not an angle.
It's just regular math. We're so used to reading it. It's making everybody.
Okay. Now that we're back, cosine of theta, we're going to draw us a little triangle.
That's a theta.
That's a theta, and this is a 3. And this is a 5. You knew triangles would be involved? That's crazy. Crazy. Whoa, whoa, whoa. Okay, so what could we do to solve this problem? We should probably find the other side of the triangle. That's a great idea. 3 squared plus x squared equals 5 squared. Right? 9 plus x squared equals 25. X squared equals 16. X equals plus or minus 4. We only care about one of those. Actually, it's a displacement. That's why it can be negative, but we only care about one of them. It is, but it is that way. It's not a distance, it's a displacement.
It's not quadriform, it's quadriform, so we like the plus.
How are we doing so far? So this is 4. How are we doing so far? Doing okay?
Makes sense so far.
Okay, now what could we do?
Usually it starts out like this. What are we finding? We're finding sine of 2 theta, cosine of 2 theta, tangent. So if we double theta.
So let's get what we have. This is the starting place. What would be the sine of theta? 4/5.
Wait. Because did we write that down? We wrote that wrong. It should be 3 on the bottom.
Yes.
Okay.
Sorry. My bad. Easy fix. The tangent of theta in case we need it, which we probably don't, but we might. Well, actually, we probably do, don't we?
We do need to get 4 over 5. Wait. No.
How about 4/3? Right?
Yes.
Great. We got puzzle pieces. Now what?
So what I'm finding is
What's the identity for the sine of 2 theta?
it's 2 sine theta cosine theta.
2 sine theta cosine theta. Do we know sine theta and cosine theta? Yes, we do. 2 times 4/5 times 3/5.
That's way simpler.
Whoa. So
24 fifths.
24 fifths.
24
24 25ths, true enough. Easy peasy, right? What about the cosine of 2 theta? That one. Yeah, that one. Let's use that one.
Which one are you referring to?
I didn't, that one. The one you said.
Let's do 1 minus 2 cosine, or sorry, 2 sine squared.
1 minus 2 sine squared theta. So 1 minus 2 times sine theta, 4/5. What's 4/5 squared? 16 25ths. 1 minus 2 times 16 25ths. 25 minus, whoa, I didn't finish writing. How about 25? There we go. What's 25 minus 32?
It is negative 7. I did that in my head in like 2 seconds. I'm so proud of myself.
Negative 7/25ths. Okay. Easy peasy. You do the same thing for tangent. You would shove it in. Math is mathing.
Math is back. This all makes sense so far.
Okay, let's solve an equation now. Are you ready? We're going to do guided practice 2A.
On the good interval. That's nice.
On the good interval. On the good ship. Lollipop.
I don't like drawing so close. It makes me annoyed. I just usually
Okay. Cosine of 2 alpha equals negative sine squared alpha. And we are supposed to solve the equation on the interval 0 to 2 pi. Right? Remember, all that means is we don't have to write plus 2 pi in at the end, right? Right? That's really what that means. Okay. Now what?
Let's find out what cosine 2 is. We should say that
That's an alpha.
2 cosines or 2. We have a sine square in here. Let's do cosine of 2x is 1 minus 2 sine squared.
That's a good idea. We should use the identity to get this to sign. And then we got the same trig function. Happy days are here again. 1 minus 2 times sine squared alpha.
We can have the same square root in this.
And then add the 2 sine degrees.
Yeah, we should move him over there. That sounds great. So we end up with 3. No. 1 sine squared alpha equals 1. Now what? I don't think we should find an identity. That's crazy, bro. Plus or minus 1. Don't forget plus or minus. What? Okay, where is the sign of alpha? 1. Pi over 2. That's true. Where is it negative 1?
3 pi over 2.
To be clear, I said this the other day. I think I've said it like twice now, but since I'm giving you all notes about what the test's going to be like, the entire test is no calculator. All of it. All of it. On a lot of them, yeah, it would be useless. You'd be punching buttons for nothing. Easy peasy. Let's do one more of these. The tangent of 2 beta equals 2 tangent beta. No, it's not a logarithm, and that would be an exponent. Yeah. That sounds like a good idea. So let's turn this one into what? Okay, now what? Now we algebra, right?
Multiply by reciprocal? No, conjugate. That's right. No.
Why?
Let's just multiply both sides by weight. And then we get,
We just, yeah, it's a proportion, isn't it?
I'm getting too excited. I'm just getting so excited. Say something I don't need. No, I'm trying to say triangle. Then you also trying to say trigonometry. Triangle.
These people drive me bonkers. Not you this time. Not y'all. Shh. Told don't know what the heck they were doing other than zoom. That's all I know.
We should subtract the two tangent data from both sides. Wait, hold on. 0 equals -2 tangent 3/3.
I like that plan.
Why am I holding on? Quit cutting up and focus.
Just like kilograms. Yeah, that's fine.
Okay, no,
Good.
It makes sense. I thought there was a mistake that was made, but I was maybe not.
That's crazy, bro. Okay. No, you're not allowed.
Where's the -2 go from the other?
Well, when 0 is divided by -2, what happens to him?
There is a mistake.
We just skipped a random step.
Tangent squared times tangent beta is tangent cubed.
It is.
He's going to start throwing markers at you very soon.
Why do I markers on myself? So the answer is 0.
And
-2. Wait, negative?
Wait.
when is tangent 0?
It's plus or minus 0.
No, it's cubed. You wouldn't do plus or minus. There's no plus or minus. Irrelevant.
Oh, yeah.
Pi and 2 pi.
But I want -0.
Number 6 is pi and 2 pi, but neither of those next two are added, so it's just pi over 6. We don't have the, it's 2 pi to start.
I don't know what chart or thoughts you're looking at, but this is what's happening, right? Because that's where he goes, right? Whoop, and then whoop.
I forgot how to read a chart for you.
Okay. You might want to start coming up with a way to memorize stuff, because that will definitely not be provided.
I was really confused how those three numbers were happening. Because
Yeah, that one gonna make no sense. That one gonna make no sense.
nobody here.
Hmm.
Here's another question.
We are going to learn some new identities.
Are we learning? Oh, yeah.
Power reducing identities. I don't remember if I said that these were going to be on the formula chart, but they are. Everything from this lesson, and I think everything from the last lesson is basically what's going to be on there. Oh no, not sum and difference. Actually, really pretty much just this lesson. All the identities from this lesson are the ones that are going to be on the thing. I don't think there's any others. Because they're ugly. Okay. Power reducing identities. This time sine gets the special treatment. Actually, just kidding. All right. If we have a sine squared, but we don't want sine squared, we can make that happen. There's an identity for that. Well, that's not an identity. That's a definition. We can turn that into 1 minus cosine of 2 theta over 2. Right? So we can have a squared one, and we can go back to double angles, and then we can get rid of the squared. We might have a new problem, but it's changed. All right? Cosine squared theta equals 1 plus cosine 2 theta all over 2. You probably could write an identity using sine. That's plausible. I'm just guessing. But tangent is sine over cosine, right? So we can just put this over this, and we get tangent, and then when we multiply this to do it, then the 2's canceled. So tangent is just this over this. Obs, yes. Tangent squared theta is 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. One more reason why write the identities in a single trig function, right? Because when we go to tangent, then we just got 1. Right? Easy peasy. Okay. All right. Do some examples with this. We're going to rewrite each expression in terms with no power greater than 1. No power in the verse can stop me. He understands. A ship, also a bug. Okay, so we are expected to rewrite cosine to the 4th of x in terms of trig functions no greater than, power greater than 1. So 4th equals bad. So what? Is this going to be a dumb question?
No, it's a question of if we take the 4th into what the
Yes.
squared equals, is it that squared
Yes.
or that?
Yes.
Okay, it's squared.
Yeah. Think about it. Because like if I said let u equal cosine squared, then I would have u, what the u one. Yeah, exactly.
Makes sense. That's what I was thinking.
Yeah.
I just wanted to make sure I couldn't do all of them.
Nope, can't do it all in one step. Right? So this would turn into 1 minus cosine squared 2 theta over 2. That's kind of useful. Sort of. We could do it again. We could totally do it again. 1 minus cosine 4 theta. Did I make a mistake already? There's something I did wrong. There should still be a cosine 2 theta in there. Hold on, let me stop for a second. Let me pause. What have I done? Oh. No. Oh, I know, because I'm trying to skip steps and he don't work. Let's try again, shall we? It's fine. Let's do it right and not skip steps. I'm trying to skip steps, just different steps than you're trying to skip. This cosine squared, cosine to the 4th x equals cosine squared x squared, right? Right? So we can take this and use the identity, right? So this would be 1 minus cosine 2 theta over 2 squared. Right? That's fine. Why not? No problem. Theta, x, who cares? Same difference.
So if we were to square this and do the actual multiplication of the fraction, would it just take that as cosine of 14?
What are you saying?
If we multiply that times that, the same thing, work out the squared, is it just going to end up simplifying as cosine of 4?
You could turn it back into that, yeah, but that's not what we're going to do. So, we need to deal with stuff. We still got squareds. Squareds equals bad. We want powers of 1s. So, we need to be able to square all of this mess. How do we square a fraction?
Multiply the fraction times the fraction?
Right. So, yes, so you're not wrong, but yeah, you square the top over the square of the bottom, right? We got to square this. I can use the binomial squared theorem, right? So a squared. So 1 squared is 1. Plus 2 times a times b. So 2 times 1 is 2. I'm getting there.
Oh, you're just doing the whole thing.
times b, which is negative 2 theta, so minus cosine 2 theta. Well, just for grins and giggles, every time I'm switch back and forth. Now it's an x. Over the square of the denominator. Oh, I didn't finish. There's something else that needs to happen. This squared plus cosine squared 2 theta over 4. Squared equals bad. We got a problem. We're just going to use the identity to turn that guy into not that guy. We gotta keep variables the same. I don't know what's happening here. None of this is difficult, right? It's just one at a time. The less steps you skip, the less mistakes you'll make. 100%. No question that is true. 1 minus 2 cosine 2x times, no, stop, lies, plus times, they're parentheses, get the idea. 1 minus cosine 2x, no, 4x, 2 times 2 is 4, over 2, all over 4. This is where we are, right? He's ugly. Now we've met the criteria, but he's ugly. So we've got to unuglify him, and then we're done. So, what do we need to do to unuglify him? We shouldn't punch him in the nose. We should definitely get rid of that 2 on the bottom. How would we get rid of that 2 on the bottom? Do you have a set of videos to learn identities or... no, I don't. I bet Organic Chemistry Tutor or somebody else does, and I know for sure Khan Academy does. You can go back a few days in my live recorded stuff, and I taught it there. So you have all kinds of options. What?
Split it up into 2 fractions. To get rid of the 2.
So yes, that would. Well, I wouldn't get rid of the 2, but. Instead of doing that, I'm going to combine all of this into 1 fraction. Right? Times the 4th, but yeah. Right? So let's get this times 2 over 2. And this times 2 over 2. Right? So we have, in the numerator, we have 2 minus 4 cosine 2x plus 1 minus cosine 4x over 2 over 4. What is the banging? Whatever the banging is, make the banging stop. Okay. Now what? An earthquake. Probably some morons outside. That's what happens when you teach homeschool classes. Sounds happen. Public school, somebody would have gone attention already. All right. What now? Times the 4th. So 8 in the denominator, right? Okay. We've also got some like terms here and here. All right, we can deal with. Yes. So we've got 3 minus 4 cosine 2x. Excuse me. minus cosine 4x all over 8.
That's still really ugly, but I think we have to.
The only difference between this and the way the key writes it and the book writes it is it pulls the 8 out to the front and just times an 8. Same. I think this is better. But it works fine. Making sense? Easy peasy?
That's the answer.
That's a big answer.
Okay.
This is kind of special, but it's
All right, let's see if we can squeeze in sine cubed theta real quick because we got different concept happening. Same instructions, but we've got to split it differently because sine cubed squared is like 6 and it doesn't work, right? We can't just do squared. So how could we break it up in a way that would give us some identities?
We do sine squared theta.
Yes. Yes.
Squared theta.
So we split it into sine theta times sine squared theta. And then, now with this one we can use identity, right? So we've got the sine of theta times 1 plus, right? Minus, because, oh my gosh. Cosine 2 theta over 2. I don't know what my brain's doing. Well, that's a little ugly yet.
So then we can multiply across the top and get sine theta minus sine theta cosine 2 theta.
Sine theta minus sine theta cosine 2 theta over 2. Yeah, easy peasy. Let's give you a little homework. Yeah, that works great.
I got 2 through 350. No, 2 through 26 units.
2 through 32 units. I agree. 2 through 32. No, we have finding the exact value of each expression. That's just 2 through 28. 2 through 28. Let me say 2 through 32.
Okay. 2 through 22 evens. Go away. Find somebody that loves them. Loves them? Loves you. Give them a hug or something.
I just like to keep him other than.
Okay. Well, don't hug they then. I guess. I don't know what